So I wanted to spend one more day on cones because I wanted to. It's my class. I do what I want. So here we go. What we're going to do is go back and talk about cones one more time. But what I'm going to do this time is we're going to use the same formula, pi r squared plus pi r l. But what happens if you don't have that L? What if you don't have that slant height piece that you need to figure out that weird blue shape? So what I'm going to do here is I'm going to kind of blow this up real quick. I want you guys to see something. I know it's fuzzy, but you'll get the idea once I start drawing on it. So what I've got here, if you notice the radius and the vertical height of the cone, where those two guys come together, hopefully you can, ooh, this is horrible. Hopefully you can see what I'm trying to outline here, right? I've got this vertical height, I've got my radius up there at the top, and then this piece right here. We haven't talked about this guy in a while, but I've got a right triangle in there. Okay, so what I can do is if I know the radius and the height of the cone, which is probably a better way to give the measurements, I can calculate that slanted piece that I need to move forward and find the surface area. So we're going to have to go back and use our old friend Pythagorean theorem. Okay, what's nice about these is I'm going to give you the A and B every time. So it's not like when we've done these before where you had to kind of switch back and forth between what was missing and what you were looking for. And, were you looking for a hypotenuse or a leg? Or it's always going to be the hypotenuse that you're looking for on these. You're always looking for the slant height of the cone. So if I back this guy back out, go away. Anyway, here, let's just slide him out here. This is what we're looking at. So I'm going to give you the R and the H, the leg and the leg. You're going to be looking for the hypotenuse. Use the Pythagorean theorem to find the slant height and then go back and do what you did yesterday. Okay, so I've set up the form a little bit different. There's the picture of the cone, and the first question is what is the slant height? Find that, and then what is the surface area? So you've got 2 steps for each problem here. All right, so first things first. I am looking for the slant height on a cone that has a radius of 6 feet and a height of 17 feet. So that is my missing side here. So 6 squared plus 17 squared, that's 325, which I need to then take the square root of. So square root 325 is 18.0. So that slant height is 18.0. So to get into finding the surface area of the cone, I've got pi times 6 squared plus pi times radius times slant height, just like we did yesterday. So 3.14 times 36 plus 3.14 times 6 times 18. 452.16, so 0.2 when I round it, square feet. Okay, I'm not going to do 1,000 examples of this. It's a right triangle. Find the slant height, then go back and do the surface area for the whole cone. So this one, the only reason I'm doing this one is because you've got the diameter instead of the radius. So you're going to have to cut that in half. 36 is 18 and 18. So I've got a leg here of 18, another leg of 42. So 18 squared plus 42 squared equal, plus 42 squared equals my hypotenuse. That's 2,088. So I'm going to take the square root of that. 45.7. I don't know if it's worth it to anybody, but your slant height, that slant height should be longer than the height through the middle because it literally runs longer. So this here, I know that I'm on the right track. This is bigger than this. If you get a slant height that's shorter than your height, you goof something up. So pi times 18 squared plus pi times 18 times 45.7. Times 18 times 45.7. That's a big one. 3,600.3 square yards. Okay. Pay attention whether you're given the radius or the diameter. If it's the radius, jump in and find the slant height. If it's the diameter, cut it in half, then find slant height.